Well, we are thrilled to have joining us now Nobel Prize winner, former U.S. Secretary of Energy, Professor Stephen Chu. Professor, thanks for being here.
Good to be here.
All right, you were the keynote speaker for the Technology Innovation Forum here in the spring meeting, which focused a lot on U.S. national laboratories as drivers of innovation. There's a long history there. If you could briefly just tell us some of the historical research that's been discovered through national labs.
Well, National Labs started with the cyclotron of E.O. Lawrence that led to the discovery of isotopes that were used in many things like medical tracers, led to the discovery of new elements that led to many things, including something useful in World War II, namely plutonium as a fissionable material. But going beyond that, they've been the discoverers of many things in fundamental science as well. The great high energy particle physics discoveries, the realization that you could use high energy particle accelerators as light sources, as synchrotron light sources, that revolutionized X-ray crystallography, material science, many things. So there's a long history of National Lab contributions.
And in recent years, research, given that history, research has moved away from industry per se and more towards universities and laboratories. Why that shift?
Well, it had a lot to do with the willingness of CEOs and the boards of companies to invest over the long term, where payoffs might be 5, 10, 20 years in the future. So the great industrial labs that we've had through much of the history of the United States, starting with things like GE Labs, which is an outgrowth of Edison, to other laboratories, RCA, Bell Laboratories, IBM, Xerox PARC. All those industrial laboratories used to do great, far-reaching research, but the pressure, often said from Wall Street, which is actually true, that if you don't reach street expectations of this quarter, your stock gets punished, and so that ends up having an impact on the leadership in the companies, as well as not only the CEO, but also the boards of companies.
Sure, you have to navigate your way through that as well. What do researchers need to know primarily when working with national labs?
First, many of the researchers know about, if you're on the basic science side, you see the national laboratories as having wonderful facilities like synchrotron sources, nanotechnology resources, and innovation centers. So they partner, researchers in universities partner with national labs.
Okay.
Many of the national labs have close associations with research universities, and I think that's a very good thing. Again, starting with Berkeley and Berkeley Lab, which is really started from a faculty member at UC Berkeley. And so those are all good things, but one of the things I would encourage people who want to deal with national labs to do is, in the last decade or more, there's been a creep towards more bureaucracy, that's also true of universities. There's more bureaucracy having, again, to do with monitoring, making sure people are doing everything exactly right, which means a huge paperwork trail, and things of that nature. And so, for better or worse, and it's really for worse, the national labs are more susceptible to that because it's more of a direct line from the U.S. government, namely the Department of Energy, to the labs that pay for much of the research done. And so that's one of the things that, while I was Secretary of Energy, while I was lab director, I was very conscious of and wanted to turn the tide and reverse that ooze into bureaucracy.
Got it. You mentioned your former position. Now you're at Stanford. How was that transition? How did that transition go?
Well, it was great. I wasn't sure after being a lab director for 5 years, nearly 5 years, and the Secretary of Energy for 4 1/3 years, that I still had it to actually begin a new program of original research. If it was just continuing what I did before, I didn't really want to do that, and throughout my whole career, every 5 to 10 years, I would move dramatically into different fields. So when I got back, I wasn't really sure, but it turned out that I had no funding, I had no space, I had no students or postdocs, and so all I could do was think, which was very liberating.
Yes.
And so my research program is off, it's running. I have now 6 group members, beginning to publish. The Stanford is now proceeding on at least a half dozen patents that have come out of the work I and my group and others have been doing, and probably going to be 8 or 10, in a variety of fields, from new bioprobes, new materials growth methods, new batteries, air pollution. So it turned out there was life after being a bureaucrat, and it's good to be back as a scientist.
Well, continued success, Professor Chu, and thanks so much for joining us.
Sure.
We appreciate it.
Okay.
Thank you, sir.
Thank you.
Yep.
Bye.